Okay, good afternoon, students. Let's have a word of prayer before we begin. Our loving Father in heaven, we're thankful for yet another opportunity to be able to examine chemistry work. I pray that you will grant these students understanding, help me to be clear in my explanations. And moreover, I pray that you will be with them as they prepare for their exams. Bless them, bless their minds, help them to retain the content, and moreover to be able to apply it in their exams so that they may have passing grades. We thank you for what you're going to do for us. We pray in Jesus' name. Amen. Okay, so we're going to start with oxidation numbers and we're going to examine some rules for assigning oxidation numbers. Now, first of all, what is an oxidation number? Now, basically, it's a number that's assigned to indicate the number of electrons lost, gained, or shared as a result of chemical bonding. And with oxidation numbers, we normally put the sign, whether it's a positive sign or negative sign, before the number, right? And we have several rules we can follow when assigning oxidation numbers. So, first rule, the oxidation number of each atom of an element in its free state, or what we say as the uncombined state, is 0. So once we have an element that is not combined with anything else, its oxidation state is 0. So in our example here, we have magnesium, oxidation state is 0, and we have hydrogen. It's not combined with any other element. Rule number 2, the oxidation number of each monatomic ion in an ionic compound is the same as the charge on the ion. So we know that for magnesium and chlorine, let me get my pen, the charge on the magnesium ion. Nikki, what's the charge on the magnesium ion? What's the magnesium ion we have? This is Mg, right? What's the charge on the ion? Mg what? Nikki, please give me the magnesium ion. Silence. Am I the only one in this group? What is it? The charge of the magnesium ion?
Must I forget?
2 plus, right?
2 plus. Yeah.
Now for the oxidation number, it is the reverse of this. We would have Mg. We put the plus first and then the 2. So once we know the ion itself, we can know the oxidation state, right? This is the ion here represented, and this is oxidation state, right? So let's take, for instance, chlorine. The chlorine ion is Cl what? You can remember, Nikki? Minus, right? So for the oxidation state, it is -1, right? That's understood that the 1 is there. Good. So once you memorize your ions, you can be able to write the oxidation states. Tell me about aluminum. Which ion you know so far? Aluminum? Do you know aluminum? What's the charge in aluminum? I'll give you the symbol here, Al. Remember the charge? Let me help you out. 3 plus. So give me the oxidation number for aluminum now. What would it be? You give me what? It's the reverse. Put the sign first and then the number. So what's the answer?
+3.
+3. See how easy it is? So all you got to do is memorize your ions, and you're good to go. You can assign the oxidation numbers and do what you have to do. All right, so that's rule number 2, right? Good.
Yeah.
All right, make sure you memorize the ions, right? Rule number 3 now. What does rule number 3 say? We still good. The oxidation number of hydrogen in a compound or polyatomic ion is always +1, except in metal hydrides where it is -1. All right, let's look here. Hydrogen, now in a compound like water here, the number of positive charges must equal the number of negative charges. So let's look at here now. You need 2 hydrogens to bond with 1 oxygen. All right, oxygen. Can you remember the charge on the oxide ion? Nikki, you gotta remember these things. 2 what? 2 minus, right? So we need 2 positives here. So this one automatically, the hydrogen is a positive sign. We can see by looking at this one, we know that we need 2 positives. So here, the oxidation number for hydrogen is a +1. You see it? Can you see it,
Yeah.
Nikki? Good. So this
Yeah,
is a
miss.
+1. But in the case of a metal hydride, this is a metal hydride here. Let's look at magnesium. We looked at magnesium earlier. We know magnesium is what? I hope you remember. Mg as well. What is the charge of the magnesium ion? 2.
+2. 2
2
plus.
plus the ion itself. But when you're talking about oxidation number, we know it's +2. Good.
Yeah.
So we're looking at this. So if this is 2 plus, you need negative ions here now, right? It's not so?
Yeah.
So
Yeah.
in this case, we need to have, and it's 2 hydrogen. So the hydrogen is going to have a negative charge.
Negative.
So when you talk about oxidation numbers now, -1. You see it? You see how it ends up as
Yeah.
-1? Good.
Yeah, miss.
So in some cases, we can have hydrogen having the +1 oxidation state, or it can be a -1 oxidation state. That's rule number 3. Any questions on that one? That was pretty straightforward, right?
No,
So we
miss.
can look at the
Yeah.
other ion and know whether oxygen is a +1 or a -1. Good. All right, let's go to the next rule. Rule number 4. It says the oxidation number of oxygen in a compound or polyatomic ion is always -2, except in peroxides where it is -1. Let's look at this one here. So here again, we know we have 2 ions combining, right? Ah, geez. I don't know what was happening there. To want to draw my G properly. Yes, let's go. This is our G. I gotta get the knack of writing with this thing. So we know magnesium is 2 plus, right? So therefore, how many negatives we need? For the oxygen
2.
oxygen has to have 2
2.
minus. Good. So is these 2 ions combine to give magnesium oxide. So if we were to write the oxidation states, magnesium is +2 and oxygen is what?
-2.
-2. Good. All right. So that's that case. Now let me look at hydrogen peroxide now. That's a different case now. So most times it's going to be -2 except if it's a peroxide. And this is our peroxide here. H2O2. Good. Let me look at this now. So this is 2 hydrogen combining with 2 oxygen. Let me look at the charge on the hydrogen then. So hydrogen is normally positive, right?
Yeah.
So this is going to be a +2 oxidation number, which means we have to have the combined, the 2 must add up to -2. So what would be the charge now for the oxygen? The oxidation state for oxygen here. It can be -1, right? Because it's
yeah.
-1 times 2 gives you the -2. So this is why the oxidation state is going to be -1 because what? It has to match up with the two ions, the two protons from the hydrogen. So this can end up being, so in order to get this right, this has to be a -1. And this is a +1. Hydrogen is a +1, right? Because it's two positives. So if we write the oxidation numbers, hydrogen will be a +1 and the oxygen will be a -1 for the oxidation states in hydrogen peroxide. So it's different for hydrogen peroxide, right? We skip this one, sodium, the sodium ion. But if you look at it, you have a 2- charge there. Anyway, we're not going to come back to that. We go forward. We can deal all that when we come across it later. All right, rule number 5. With the exception of hydrogen and oxygen, the oxidation number of elements in covalent compounds and polyatomic ions may vary. So you can have differences in covalent compounds and polyatomic ions. They're going to be different. The oxidation number may appear in the name of the compound or the ion. Look at here. We have sulfur 6 oxide, right? So let's look at this one here. This is our ion. This is our compound here. We know that oxygen is normally what? -2, right? In this case, right? So you have 6 negatives in all. So what gonna be how many positives do we need? If we got 6 negatives, how many positives do we need for sulfur? The oxygen tells us that we have 6 negatives. How many positives do we need for sulfur for it to cancel out each other? We need +6. We need 6 positives. Right? You understand, Nikki?
Yes, miss.
Good.
Yes,
All
miss.
right. But if you look at this one here, it's slightly different. All right. Let me look at this one. This one is slightly different, right? Look at this one now. Notice they have sulfate 4. But look at the charge. This one has a 2- charge. SO.
Yeah.
You notice the 2-, right? So it means you have 2 negatives left over. 3. All right, good. We know that oxygen is normally what? 2-, right? And if it's 2- times 3, is going to be how many negatives needed to cancel out the positives? How many negatives in all do we have? 2- times 3. How many negatives do we have in all in this compound? Wait now, you. 6 negatives, right? But notice you have an extra 2 negatives here. So that means that this has to be a +4 to end up with that extra 2 negatives there. So when you add the -6 plus the +4, you end up with a -2. Look, if you add the -6 and the +4, how much would you be left with?
I know.
-2. Good. And this is why we have this here, the -2 here. Okay. For that ion. Good. So basically, to know the oxidation state of this, we add. What we could have done is take the -6 and minus the charge on the ion, then -2. We add this. No, we want to do it away. Leave it away. So from the name, you see it? -6 plus 4 leaves a -2. Good. And this is why we have a 2 minus charge here to account for the extra 2 negative charges. I hope you're following the one.
Yeah,
You
make
follow the
a
piece,
fine.
right? Good. So
Yes.
this is why we end up with a -2 there, because we have extra -2s that don't have any positives to cancel them off. All right, good. All right, my girl is following. We can learn about deciphering the oxidation number of summing up the oxidation numbers soon enough. Good. So that's rule number 5. All right?
Yes, miss.
Good. I got 2 more rules to look at. Rule number 6. The sum of the oxidation numbers of all the atoms or ions in a compound is 0. All right, here we go again. So when we have a compound, if we were to add up the oxidation numbers, what can be? 0.
0.
So in here we have, oh, I'm hearing another voice. Let me see who's the
This is
other
just my
person.
cousin.
Oh, it's a
This is
cousin.
my cousin.
All
Yeah.
right, welcome, cuz. You're listening in.
This
Good.
is a
So,
he.
pardon?
This is a he.
Oh, it's he. Sorry, he is here. Welcome. All right, good. Yeah, so we look at rule number 6. So whenever we have a compound and we are to add up these charges, it will be equal to 0, right?
Yes, miss.
So when we adding up the charges in the atoms or ions, it's going to be equal to 0, right? So here we know we have Mg2 plus, which is going to be a +2. And for chlorine, we're going to end up with a -2. And we add them together, we end up with 0. So whenever you see these compounds together, their oxidation state is 0.
0. Okay.
Good. If you were to add up what the oxidation states in the compound. All right, let's see. The sum of the oxidation numbers of all the atoms in a polyatomic ion is equal to the charge on the ion. This is similar to what we did here, right? If we were to add them up, let me see, show you back our example. Where we were here, we were talking about it here. SO2 minus,
Yeah.
where we added the +6. Sorry, where we added the +4. We added the +4 and we added the -6. And we end up with what? Now -2?
Yes, miss.
And that is the charge on the ion. Notice the charge is here, -2. So we're going to go to our example there. That's in 7. So let's check this one out.
Okay, miss.
All right, I gotta erase this one. Good. So if we were to add up all the oxidation numbers in the atom in a polyatomic ion, how do we know it's a polyatomic ion? First, you're going to see 2 or more elements and you'll see a charge on the ion, right? So if we were to
Yes,
add
miss.
them together, let's look at oxygen, right? We know oxygen is a -2, right? Right?
Yes,
Good.
miss.
But in this case, if oxygen is -2, that means the hydrogen got to be a +1.
Positive note.
Good. And when we add these two, we end up with a -1, which gives us the charge on the ion here. You see it? The relationship?
Yes, miss.
Good. So that's our last rule. So they had some questions here for us to look at. Let me see. Right? They haven't told me I'm left for 10 minutes yet. So we're doing good with time. So we get to work some questions. Good. So they end up to tell us here, if these rules are followed, it is possible to determine the oxidation number of any element from the formula of the compound or the polyatomic ion it is in. So we can pick out any element and be able to say, all right, this is the oxidation number for this particular element following these rules. All right, let's look at this one here. All right, so they give us an example here. Let's look at NO2. NO2, this guy here. NO2. All right. All right. So let's look at oxygen. What would be the oxidation number for oxygen, Nikki? Looking at this compound here. -2. Good. So how many negatives we have in all here? So it'll be -2 times 2 gives us -4, right?
4.
So that means how many
Yes.
positives should we have for nitrogen to cancel it out?
4. No, not 4. Pardon me?
Yeah, +4, he's right. You need +4. So this is why nitrogen would have a +4 oxidation number, right? So it's an easy way to
Yes,
decipher it. So we look at rules 4 and 5, applying it here. Good, that's what our example there. I hope you understand that example. All right. So we go on to another example. So let's look at NO2 minus now. So this is an ion now, right? Good.
Yes.
Let's go. So this one can be slightly different. Let me see if we can work this one out. Work this one out and let's work this one out. So we end up with NO. It's an ion, right? So this is a polyatomic ion. 2 minus. That's what we start with, right? So right away we know that we have -2 times 2 to give us how many -4s? To give us how many? And don't tell me the answer, -4, right? But notice there's an extra negative here. The only way we can get that extra negative is if we have a +3 for the nitrogen and we're adding it to the -4, right? So if you plug this in your calculator, you're going to know you're left over with -1. So in this one here, the nitrogen is +3. Why? Because we have a charge left over here. This is our charge that's left over. So in order to get this NO2 minus, the nitrogen is +3. Hope you follow the pattern. Right? In this case, we looked at rules 4 and 7. I gotta give you some. What I'll do now, during the week, I'll give you guys a few questions to work. After we finish the first experiment on Monday, we can look at some examples to work this out. Goodie.
Miss Anna, there's some discussion for your check on the PD lab.
Okay, no problem. All right. We have nitrate here now. All right, I don't think I want to go into any more else today. I want to leave you guys to have that lingering in your brain, and then we'll look at determining the oxidation numbers. I'm gonna leave this last part for you guys, just the rules we're gonna look at.
Okay, Miss.
All right, so we're gonna stop there for today. Thank you for attending class. So we're gonna stop now. Bye-bye.
Bye.